Hello and welcome everyone. Thanks for joining this session about DevSecOps for network operations. My name is Akash Bhaskar. I work for Cisco here at San Jose. I am a software architect with interests around site reliability engineering, automation, and CI/CD. Being in the Bay Area, I try to take advantage of the sunny atmosphere and do some swim, bike, run, paddle, kayak, scuba. So if you are interested, go ahead and connect with me on LinkedIn and we might do some stuff other than the DevSecOps. So in this session, the idea is to teach network engineers or network architects to attain an automation about their network operations. And the way we are going to do that is through DevSecOps tools out there. So we will discuss about bunch of tools which are present in the market, how to take out specific tool from a specific category and put it to use. What should be a recommended core stack look like, and then we're gonna end with couple of use cases and some bonus use cases. Let's break down DevSecOps network operations a little bit. Why do we need it? What is the importance? So DevSecOps is a methodologies or process which move a network engineer away from tedious manual processes and build CI/CD pipelines or integrate systems such that the new network operations are much more reliable, efficient, observable, trusted. Here we talk about network operations. So our infrastructure is switches and routers. The use cases revolves around couple of areas which are configuration compliance and software compliance. We'll look more about these in upcoming slides. DevSecOps is, as I told you, it's basically implementing CI/CD pipelines, which includes having components like code management, artifact management, static code analysis, quality, code coverage, validations, among others. So let's look at some of the tools out there. So things to note here is the list of tools displayed on the screens are not exhaustive. You are free to choose any tools out there. Maybe some of them are you are using already, and the idea is you can use with your existing tools. This process is tool agnostic, but we need to learn about how to manage our code. What is the best tool out there? What is continuous integration? How to manage our artifacts? How do we validate or verify our configuration and software before making changes? How to keep our inventory? What kind of observability measures out there? What is the security aspect of pipeline? So the key idea here is to understand the idea around each categories and implement a tool from the stack. So let's look at a recommended tool stack from numerous tools out there we just discussed. So our core stack, what it looks like is, or what we are going to use to achieve our use cases is, basically we have code management tool as GitHub. Then we're gonna have a CI engine, which is Jenkins. It's quite popular and easy to use, plugin based scalable engine. We're gonna use static code analysis and security as per SonarQube analysis. We're gonna perform some change validation in terms of pre-post checks. And the way we're gonna orchestrate our changes is using by Ansible and Ansible AWX. And at the end, once our change is deployed, we're gonna move those artifacts to an artifactory management tool such as JFrog Artifactory or Nexus. Let's look at the first use case about configuration compliance. The way or the flow of this use case starts with there's gonna be an upstream system or a human who might be pushing some changes to the network infrastructure. The way change is gonna move is it's gonna reside in your code management or version control, let's say GitHub. Once your CI engine such as Jenkins starts executing that change, it's gonna check out the configuration files and automation files from your code management system and then build those configuration which are going to be pushed in your infrastructure and apply them. In this use case, we're gonna use netconf, which is easily available in Ansible and its modules. And then once we made those changes, this will be validated by comparing some pre-post checks, and after that deployment we're gonna move the verified changes into an artifactory called Nexus. So once again, idea is to have a continuous integration system which can observe and monitoring your pipeline. And thus the way stage is gonna be defined is gonna be atomic. We're gonna achieve a specific step throughout your pipelines. Some of the example of those stages can be: first, you're gonna perform a static analysis, a sonar cube analysis. It includes some of the quality gates you might implement. Then you're gonna build the configuration which are desired to go in your system using the configuration file present in your version control system and the variables. And once you apply those configuration into your network, you can validate it using some system, for example like Badfish, which is an open source tool which only needs a running configuration and doesn't connect to your remote network device to validate network related configuration. And once you push those configuration using your orchestration such as Ansible, we push these verified configuration to Nexus. This is a quite descriptive way of how a Jenkins pipeline look like and the stages, the way they are coded. Jenkins give you functionality to hover over these green boxes and look at the logs even. Let's look at the pre-post checks of our configuration compliance use case. In this use case, we are adding a EBGP neighbor in couple of switches, C8KV switches for example. In this screenshot, the BJP is not active in the first run. But after we have successfully executed the pipeline, we can see BGP configuration available in both the routers. This process takes away the manual and tedious task of network engineer on having a downtime and running some scripts and error prone process to a well automated, version controlled, reliable, efficient, trusted process which can be run over and over and over again and achieve the same desirable result. Let's look at use case number 2, which is about software compliance. In this use case, instead of making configuration changes, we are upgrading any device in our network infrastructure. Once again, changes can be started from an upstream system or from a user, and as soon as it hits the CI/CD engine or we start the pipeline, it is going to check out the code and configuration from the version control. This use case specifically has a step of USD, which is showed here at number 4. It's a special tool which we developed here. It downloads the software from software.cisco.com and stage it to our own devices or our network devices. Whoever wants can take this task out and do it separately, but it depends on whatever process you have to download and stage the software. Once software is staged, the pipeline will trigger playbooks. In this use case, again, we are using Ansible and Ansible AWX. Whatever solution that you choose, those playbooks would be executed one by one, including pre-check, specific change, post-check, and upgrade your network infrastructure or your network device. When the device is successfully upgraded using the pipeline, the said software is pushed to your Artifactory so that it can be promoted to your upper environment such as production. Here's a screenshot from the Jenkins pipeline of this specific use case. Once again, this is to showcase how to use CI tools and how we can build stages, what stages should be there, how to implement each stage, such as SonarQube analysis, downloading software, staging, performing a router upgrade, and doing pre-post checks and publishing image to Nexus or Artifactory. At the bottom of the screen, we can see the pipeline shows the result of a pre-post check, which tells you that the software has been upgraded. Use case number 3, it's cloud native pipeline that is achieved using cloud native, or let's just say AWS native tools. This list is again not exhaustive. Whichever public cloud you are using, you can take out those tools and implement these tools, these pipelines using those tools. In this use case, what has been done is there is a C@KV in one of the VPC, and AWS has this code build, code pipeline, and code commit, which can be used to run steps present in your build spec YAML, which again, it's like a CI engine, a YAML file, set of instruction. Left bottom of the screen shows a container, Elastic Container Registry, which has the container which code build is going to use to execute the instruction. The way it is done is code build is going to connect to the C@KV router and then execute Ansible playbook to make changes to C@KV device. This screenshot shows an example execution logs of changing HTTP server status in a C@KV. Once it was enabled in the beginning, the pipeline is disabling this simple configuration, and the idea here is to show that the simple configuration changes can be scaled up and make bigger changes in your network infrastructure. Having discussed these 2 or 3 well-used use case out there, there are a couple of potential use case I would like to share with you guys. These revolves around SD-WAN. SD-WAN is again, if I try to lay it down, it's like a platform which can manage your edge devices in software way. It has a control plane which contains vManage, vBot, and vSpot, and there are a bunch of vEdges which are managed by that. Even such platform can become tedious to manage if you have multiple customers and multiple SD-WAN. So to automate them, there can be a platform which takes care of its upgrade, and it can involve stages like readiness, upgrade, pre-post check, backup and restore. And once we do these things, it can be put into a pipeline. Another potential use case is, again, it is SD-WAN disaster recovery. It's for the customers who are using active passive cluster or primary secondary vmanage. There are simple steps. It works using the APIs present on SD-WAN, and this can be built into a platform and put it inside your DevSecOps. So those were the use cases I'd like to share it with you guys. And once again, the idea here is for you to start building your own use cases, own DevSecOps pipeline based on the use cases that I have shown here. And to start with, I have shared a sample code on my GitHub account. You can look at it and start building CI pipelines based on that. Some of the introductory documents around Badfish, Nexus, and SonarQube, which we discussed in this session, the links are out there. Please go ahead, read, and start using them. And with that, I'd like to end this session with a reference that the similar session is recorded and published as part of our Cisco Live US in Las Vegas in last year. The link is provided to look more into the presentation material and listen to the speaker talking. This is it. Thank you so much.